Hey everyone, this is Siddharth. So today we will be solving another question on lead code, which is maximum subarray. So what we have to do in this problem is that we have to find the maximum. We have to find the subarray which has the largest sum in this given array. So how can we solve this problem? So one approach to solve this problem is to use the brute force method, in which we will traverse into the array. We will find all the subarray of this array, and we will take the maximum. We will take that array which has the maximum sum. In this way, we will able to find the subarray which has the largest sum. But that that approach is not that efficient. It will take omega of n square time, and that we don't want. We want to solve this question in linear time, which is in a single traversal. We have to find the subarray which has the largest sum. So let's start. So we will use an algorithm which is Kidaine's algorithm to solve this question. So let's move to the screen what we will going to do in that. So first we will take a variable which is sum and initialize it to 0, and we will take another variable which is maximum. It will take care of the maximum sum. It will take care of the maximum sum in the array. We will initialize it to the integer's minimum value, which is integer dot min value. So now what we will do, initially the pointer is at -2, so we will add this -2 to sum, so our sum become -2. Now we will check if this sum is less than 0 or not. If this sum is less than 0, we will update our sum to 0 again, because carrying a negative number forward uh, is useless. Like why we have to carry the negative numbers? So we will initialize our sum to 0 again. Now we will move to the next element in our array, which is 1. Now again we will add this 1 to our sum, so our sum become 1. Now the sum is not less than 0, so we will move to the next element, which is -3. Now we will again add that to our sum, so our sum become -2, which is less than 0. So we will update our sum again to 0. Now we will move to the next element, which is 4. Now we will again add this element to our sum, so our sum become 4, which is greater than 0. So we will move to the next element, which is -1. Now we will add this to our sum, so our sum become 3, which is greater than 0. So we will move to the next element, which is 2. Now we will add this 2 to 3. Now we will add these two elements, and our final answer become 5. So we will move to the next element, as 5 is greater than 0. So we will add that this 1 to 5, so our sum becomes 6. Now our maximum number is 6, which is greater than 0, and we will again move to the next element, which is -5. So after adding -5 to 6, our sum become 1, and our maximum is 6, because we are updating from the start. After adding the number to sum, we are doing math.max of sum and max. So the highest value that we got is 6 right now. So we will add 6 to -5, so our number become 1, and which is greater than 0. So we will not update our sum to 0. We will move to the next element, which is 4. So our now sum become 5, but our maximum is still 6. So we will return a maximum number, which is 6, and 6 is the answer. So we are in this way we will able to solve this problem in linear time complexity and in an efficient manner. So let's code this out. So what we will do, we will take initial sum as 0, and we will take maximum or max so far. uh, that will be more, this is more clear. So we will take it to integer dot min value. Now we will start traversing the array. Let's comment it out. Traversing into the array. Now we will start a loop int I equals to 0. I is less than nums dot length I plus plus. Now what we will do, we will add the current element of the array into a sum, which is sum is equals to plus nums I. Now we will update our max so far. So max so far is equals to math dot max sum and max so far. Now what we will do, we will check if the sum that we got is less than 0. If it is so, we will update our sum to 0, because we don't want to carry the negative number forward, which is useless. Now what we will do, we will return max so far. So I think code is looking fine. So let's run this. Okay, all the cases have been accepted. So let's submit this question. So we have solved this question in an efficient manner. So thank you. Bye. See you in the next video.